Hello, everybody, and welcome to TriStar's webinar for today. Our introduction to Onshape, speeding up and modernizing your product design process with cloud-native CAD development. My name is Shawn Schreckengost. I'm a TriStar Business Development Manager. Been with TriStar for about 9 years now, and got probably close to 40 years in the industry, and spent some time with PTC as well, and several years out in the industry. And today we're going to share with you some of the progress with cloud native CAD tools, specifically with Onshape. And we're going to talk a little bit about the history of how we got here, and then do a demonstration of the tool, and then open up for answer any questions. I think I have maybe about 45 minutes worth of presentation here, so let's go ahead and get started. So if we talk about digital transformation to the cloud, way back in the 60s, a lot of computers were mainframe, if you will, systems where we had a big rack of computer cables, and the data was stored, on this DAT tape system, if you will, and loaded onto this mainframe system that we accessed from a workstation. And then, in the 80s, software kind of moved into more of a client server type application where, we still we're accessing a server, but we had software loaded on the client itself. And a lot of business type softwares were moving to that type of environment, and some of the early CAD systems were using that type of an infrastructure. Well, today, of course, we got a lot of applications that are available to us in the cloud. And Onshape is one of the first CAD systems to move to the cloud, to where we have everything that you need in the software is SaaS-based service as a software as a service application. So if you think about some of the data that we use today, some customers might not be too happy that you have data on your local machine, that we're sharing files, and other people might have access to it. So one of the nice things about cloud computing applications is that data is all stored securely in the cloud environment. So if we talk about why product development is lagging behind in some of these applications, is that we started years ago doing product development in a drafting room on a drafting board using vellum and ink and drafting machines. Well, all of these paper-based systems were very archaic, and we really weren't sure that we had the right data in front of us, and a lot of this information was stored in a file cabinet, not necessarily in a vault or a PDM system. Now, I actually got my start back in the early 80s working in an environment just like this, where we had a drafting board with a drafting arm, and we had electric erasers. I mean, if you see this right here, this guy's got an electric eraser hanging from his drafting board. Well, that might as well have been me back in the day. Well, one of the things about this type of environment is, all the drawings that we were working on were stored in a file cabinet, at the front of the room. And if you saw that in that previous picture, all of our drawings, were in a file cabinet. And if we had to, create a new drawing, we would finish the documentation, and it would be stored in this cabinet and ready for review and approval and release. And if we had to make changes, we would get change requests, and they would come in a paper format, and we would store that in the drawer, and we would go to the drawer and take out the drawing and make those changes by hand to those drawings based on the change request. Now, this is all the the way we worked back then. Okay, and you know, in the early 80s, I remember working in a system that was a mainframe, and it was computer vision CADS 4. And this was out in China Lake, California, where we did support for naval airborne weapons systems. And you know, here we see a fighter jet with a couple of airborne weapons hanging from the wing. And if you look down here, we see this is actually called a Sparrow air-to-air missile, which is a radar-guided missile. And then below that, we see on the wingtips, which is typically where your sidewinders are mounted and launched from. And the sidewinder is a heat-seeking weapon. So the difference being is that in a heat-seeking weapon, you have to get close enough to what you want to shoot down to read the heat signal. Well, when we were, you know, supporting these weapon systems, you know, everything we did was on a, you know, a terminal-based system like this that accessed the mainframe. And here you can see the computer vision logo on this screen. And this is actually the same hardware that I worked on, where we had a digitized tablet with a pen. We didn't have a mouse. We had a pen with a couple buttons and a wire going into the system, and then a keyboard off to the side and a printer next to us where we could, you know, print out whatever information we needed from the tools we were working with. The way this system worked, though, is that nothing was loaded locally. We had to access all of our data from a disk pack that was in a separate room, that was loaded up in the morning. And every morning we would come in and we would have to fill out some paperwork as to what we wanted to work on for that day, and that system, what terminal we were going to sit at. And you know, somebody would load that data onto the disk pack, and then the disk pack would be put into the machine so that we could access the data. And you can see these disk packs, there's, you know, probably a dozen disks that are about the size of an LP. And, you know, I don't think they held very much data back then, but that's what we had, right? Well, to get that data onto those disk packs, there were machines that would read the data from a DAT tape and put it on the disk pack. The disk pack would go into the machine, and then we would access that from the terminal. And then at the end of the day, when we were done with our work, somebody would load that data back onto the DAT tape, and then that DAT tape was stored in the vault. And that vault actually looked just like a bank vault that you might see today. And that data was securely stored. So there was nothing left to access from the terminal, because the disk pack was removed, and then that data was stored on the tape, and the tape was put in the vault. And then the next day we would come into work and we would fill out a form as to what projects we wanted to work on and what data we needed to have loaded, and that would start all over again. So you can imagine, you know, the sheer effort that went into working in that type of environment. But that's where I got my start working in CAD. So just a little bit of a history lesson there. Well, you know, in early 80s, you know, the first, I guess, PC-based CAD tools that you saw out there from Autodesk were AutoCAD, right? And I remember those systems coming into the Navy base where I worked out there in China Lake, California, which is in the middle of the Mojave Desert. You wouldn't think a Navy base would be in the desert, but that's where they do a lot of the weapons testing. So I remember these AutoCAD systems coming into play, but you know, they were just really kind of 2D based, you know, making drawings, but I mean, pretty affordable, right? Then in the early 80s or later in the 80s, PTC released Pro Engineer. Of course, a little bit more expensive, but that worked on a Unix workstation where we had, you know, full 3D capabilities, solid modeling, that kind of stuff, right? And then in the mid 90s, the SolidWorks, you know, and SolidWorks basically was developed by some, you know, people who used to work for PTC, but that, you know, was available on a PC 32-bit system. Of course, we've come a long way since 1995. I don't know if you remember 1995 when you could get a 100 gigahertz whatever chip to run your computer, and we thought that was pretty fast back then. But you know, we've come a long ways. So, you know, the one thing that all of these systems have in common is they produce files, right? And we have a file that we put on our hard drive, and we maybe send it in an email, we share it with somebody else, but they're all files, right? And, you know, files aren't necessarily the latest and greatest. When I send a file to somebody and they have it and working on their system and I make changes to it, they don't have access to those recent changes unless I actually send them that information, right? So there are some problems with that. But really what we've done is we replaced that old drafting room environment with the file cabinet in the front of the room with an electronic version of that, where we're still sharing copies of data and loading them onto our computers and sending them, you know, via email or, you know, thumbnail drive or what have you, so that other people can access that. So we really haven't gotten to a point where we're not sharing copies of files. So, you know, what's wrong with files? You know, they're you know, just versions, right? You know, if we think about the innovation timeline of product development, we have, you know, a user that's creating data on a CAD system. They create many CAD files. They, you know, send that data to their suppliers and other departments. You know, they create email copies or thumbnail copies, and, you know, still more copies, and somebody else takes that data and they make changes to it, and then they send it off again. And we just really are creating more and more copies of data. Even with today's PDM systems, you're still kind of sharing copies or versions of CAD files. So it's really not much different if you think about it, other than it's electronically done versus on paper that we used to do, you know, back in the day. So again, we're working with copies, you know, many users accessing various copies or versions and so on. And the real problem with this is, you know, how do we know what is the most recent current version of the data? And we really don't. You know, we have some idea, but even still, there's chances of that data not syncing up with what really is the latest and greatest, right? So, you know, not that they're the root of all evil necessarily, but we see a lot of scrap and rework and intellectual property theft based on files, because when I send that data out on an email, who knows where it goes or who gets a hold of it, right? So, you know, that's, you know, some of the problems that we have with sharing files. So what I want to share with you today is a quick demonstration of Onshape. And then we'll have a few more slides, and we'll open up for some Q&A. Okay. So what I have here, if you can still see my screen, I'm going to open up Onshape. And when I log into Onshape, you know, basically, if I go to my home page, I have, you know, a menu here to the left with, you know, what have I recently accessed or created by me, shared by me. I have, you know, access to learning content, which is really kind of nice, is that in my fingertips here, I can go to the Learning Center and I can take self-paced courses, right? So learning pathways or self-paced courses. And these are available to me. So I can select any one of these courses to work with. So there's all kinds of nice information that's available at my fingertips for working with this tool, right? I also have these folders that I've been working in, and I created some data to share today. And I want to open up this bolt cutter that I created. And I've got a couple of versions of this that I'm going to share with you today, just so that we can kind of walk through how this tool actually works. So what you're seeing here is basically a 3D assembly of this bolt cutter, right? And these are parts that I had created within this document. And, you know, this has mechanism capabilities where we can drag this to, you know, see how this works if we want to, you know, zoom in to, you know, check out the data. but this assembly is part of this document. And if we look at what's available in this document, in this Onshape document, we have a part studio, we have assemblies, we have drawings, and we have subfolders, and we can import data. So what I have here is I have an assembly and I have a part studio, right? And in this part studio, this is where I would actually do the modeling of my parts. And this system is, just like any CAD system that you've probably used, where we might create some sketches, right? In this case, I created a sketch that represents the layout, if you will, of this bolt cutter, right? And then I created another sketch that represents the outline of the blade and maybe the link that joins the blade together. And then in this tool, I mean, we've just got sketch geometry, we've got lines and rectangles, and they work basically just like any CAD system out there, right? So we've got constraints, we've got geometry, symmetry, all those kinds of things that you would typically use. So I don't want to necessarily belabor this process, right? So what we do with this these sketches is then we create extrusions or sweeps and so on to create our solid model. So if I were to drag my history bar up to this rollback up to this location here, and let's just take a look at one of these sketches, and I'm going to turn that on. Basically what I want to do is select the sketch region, and if I select that sketch region, what can I do with that? I can extrude it or subtract it or whatever, so this is not that it's any different from a lot of CAD tools out there. It very similar, but these are the things that I can do with these shapes. I can make that be symmetric. I can use different depth options, just like you've seen with other CAD tools. So again, I don't want to necessarily belabor that tool, and then we're just going to roll back to the end. So that's how this tool works, right? And this being in the cloud, everything that I do is being recorded. Okay, so if I look at my versions in history here, I can see everything that is happening today, right? So I did a rollback, I did a show. I mean, everything I'm doing is being recorded, okay? So it doesn't matter who's doing it. It could be real time. Somebody else could be working on this assembly at the same time I'm working on it, and I would see what they're doing, right? I can also create versions in this system. So I can say, well, what is, I want to roll back to that version there, or what version of the tool was that? I want to go back a little bit further, and I can save these versions at any point in the history of the model, right? So I can take, this main version history here, and I can say, well, at this point, I want to create a version here, right? So then I can go back and forth and basically creating a snapshot, if you will, at that location. Okay, so very neat that I can do these types of things. And in a later presentation, we'll get into more of the history and versions here, where we can do some branching and some other higher end capabilities, but I don't want to get into that today. So that's kind of a introduction to just kind of the interface. We've got our I can change my views over here, look at it from different directions and so on. I've got some different appearance panel pop outs and things like that I might want to use. Okay, so what I'm going to do is I'm going to go back to my main page here, my documents page, and I'm going to open up a demo that I want to work on. So this I just basically made a copy of that to show you a few things here. And one of the things I want to point out before we get started doing anything is that when I open this, I see that this JP is actually active in this document, or this part studio. So I can actually collaborate with JP if I wanted to. So I can say, hey, send a comment to JP and say, hey, I see your in the document. All right, and I can send that to JP. And JP gets that message that flies up and on their screen, and JP might respond. And I've actually got JP running on another machine, so you know, and JP is going to respond to me, right? So when JP responds, it instantly on my screen, I can see that, and JP says making changes to the link, right? So okay, let's close that, right? I don't want to see that anymore. Of course, my GoToMeeting is in the way. Sorry about that. All right, so let's see what JP is doing. All right, so if I double click on this icon, I'm now following JP, and anything that JP is doing, I'm going to see, even if she just rotates the screen, right? And we can see what she's doing. Maybe she's going to zoom in, and maybe she's going to make some changes. So everything that JP is doing, I'm seeing, right? So maybe she's going to make a change, right? She's going to edit the link and change value. So everything that's happening, I'm watching, right? So at that point, I say, okay, I see what she's doing, right? Maybe I don't want to follow her anymore, right? So I'm gonna turn that off, and I'm now looking at my own screen. But if she were to make changes again, I would see that real time in this window, right? So for example, if she went back in and changed that extrude again, instead of watching her though, I'm actually seeing what she's doing. The moment she does it, my system is going to update, right? You see that? So that's one of the great things about working in the cloud, is everything that's happening is happening real time in the cloud, even when I've got multiple people working in the same document. And I can go up here and look at my versions and history and see what's happened today, right? So there's been some edits by JP, right? And so on. Okay, so I can actually see all what's going on. So I'm going to make one more change here. We're going to edit that one more time. JP is going to do it, or maybe I can do it, right? But I'm going to change it back to 0.125, right? And we'll check that. And as soon as that gets uploaded, I see those changes in real time. All right, so that's pretty much how the modeling piece of this goes, and the collaboration. So let's go to the assembly here. I'm going to show you how easy it is to work in the assembly on this. Now, I've got all of the parts from my part studio that I've added to the assembly, although I'm missing some handle, one of the handles here. So we'll go ahead and add that and show you how that works. So I'm just going to go here to insert. And from this part studio, I have all the different parts that were created, right? So if we go back to the part studio real quick, we can see here I've created all these different parts within this part studio based on the sketch geometries that I have. Now, these parts are created just in space, although it looks like they're created as an assembly. They are really just parts that are created kind of in the same orientation that they would in the assembly, just so that I can get those interrelations between the parts created, right? But when we go to the assembly, they act as just parts. Okay, so I'm going to go ahead and insert here another handle, and we're just going to drop it right there. And I'm going to insert another grip, and I'm just going to put it right there. And we'll say okay. And then I'm just going to assemble them after I've got them in place. Now, with Onshape, when we create these assembly mates, we've just got kind of a couple different options here. The primary one is a fasten mate. And when I do a fasten mate, I'm going to pick one part that I want to mate. And these mates are basically, these mate connectors are kind of all over the place on these parts, depending on what geometry that you select. And I'm just going to use this little mate connection here. And then I'm going to put it in my assembly right here and kind of get it right where I want it on the end here, which is basically right there. And that, Oops, do that again. Create the mate. That one goes to that one. And then that gets assembled just like that. Okay, now if I had to, I can flip it in the other direction, and I have some other things that I can do with that. I can change the type of mate if I want to make it cylindrical or revolute. And then these things have some freedom of movement, okay? But for the most part, I'm just going to use what's available to me, and we'll accept that, okay? And then we'll do the same thing with the handle here, or the grip. I'm going to take that one in the back right there off of that cylinder, and then we're going to match it to the cylinder here at the end, and that's assembled. All right, so very, very easy to create these assemblies. Now, when I insert, I basically start with what I've created in this part studio. Okay, I can also select sub-assemblies. I can pull from other documents. I can even use standard content, right? So I have a library of nuts and bolts and so on, right? So what I'm going to do is I'm now going to assemble the pins that go into this handle. And to do that, I'm just going to hide this handle from view. I don't want to see it right now. So I want to drop those pins right in place on this lever part here. And so we'll go to insert. We're going to go to standard content, and we'll go to pins and studs, and I think I have a spring pin, that one right there. We'll insert that. And you can see that it just kind of wants to snap into place here. And I'm just going to roll this over so I can try and get the right snap geometry. There it is right there in place. I can insert another one, and we'll put that in place as well. Okay. We'll accept that, and we'll turn that handle back on. Okay. One of the other things I need to change here is when JP made the change to the thickness of this link here, our bolts became too long. All right, so we just need to swap those out real quick. I'm just going to right click on that, and we're going to replace that with a new library part, and we're going to go to the nuts and bolts, I think, bolts and screws, hex bolts, and in this one we want, I think 0.875 might be the one we want, and there we have it. We'll accept that, and then we'll replace the same one here. Okay, just that easy. All right. So I'm going to go back to the part studio. We can still see that JP is actually active in this. So, and not that that's any concern. We're working collaboratively. I could send messages to JP and say, hey, I'm going to create the drawing or whatever. But what I'm going to do is I'm going to create a drawing of this link. And with that, we have a choice of formats to choose from. Whether or not to have views, I'm going to say no views with this, and we're going to say okay to create the drawing of the link. And we could have our own library of formats. This is just a format that comes with Onshape. It's a default. I can create my own, and we'll get into that in some later presentations. But for now, just using what's out of the box. Now, as I move my cursor around, we can see that that wants to put a view of that link on this drawing. And here we have the insert view. It's kind of automatic. The moment I open up a drawing, it assumes I'm going to create a view. I don't have to. I could cancel this, but actually I want to just change this to be a top view, and I'm going to change my scale and make it 1:1. All right, and then we'll put that right there. Okay. If I want to, I can create a projection view automatically here, or I can say that I want to create a cross section, and I'm just going to drop that cross section right there and put my view here. And it's automatically sectioned for me. All right. So very, very quick and easy. Very similar though to some other tools that you may be familiar with, but it's in the cloud, right? So everything I'm doing, JP has access to this drawing immediately. She can open it and take a look at it, right? And so, we have, our dimension tools, just picking on some geometry. Maybe I have a prefix to this. I want, 2 places and maybe an appendix. It's through, whatever that might be, and automatic. If I wanted to add some geometric tolerance to that, I can add it to that dimension, and whatever that tolerance is, it's, whoops, I want to add it to that dimension there. And 0.010 tolerance might be at a diameter tolerance zone at maximum material condition, datum's A and datum B, perhaps, right? That one I want to get rid of. All right, a few more dimensions here. Maybe we want a width on this. Maybe we want a thickness here. Okay, so as you can see, very, very easy to create drawings, very similar to other systems. And a lot of this format information would be automated if I had created parameters in my models or filled out the parameters that come with the models. These formats would be created automatically, propagated automatically. So at this point, I'm ready to maybe release this document. So I'm going to go ahead and select release on this and give it a part number, whatever that part number might be. And we can use the same thing here. Okay. And then my approver, I'm going to say JP is my approver. And we will set out the release name. And we'll submit that. So at that time, the moment I submit this, JP is getting a notification that this is requested for release. And then she's going to get that notification. She's going to view the release, and she's going to make a comment. And maybe reject the release. And if she rejects it, then I'm going to get a notification that that release has been rejected. Okay. We see that it's been rejected. We can expand on that. And she's saying, please change the thickness of the link. Okay, so we can complete that change and then resubmit for release. Now in a later presentation, we'll come back and we'll get into more detail of the full release process with Onshape. But at this point, I want to go back to my slide presentation, and then we'll open up for some Q&A. Okay, So, I mean, seeing what you've seen here in just this very short demonstration, we talk about how the existing tools today are actually constraining our product development. If you think about the IT support and overhead, it's a huge burden on financial resources within our companies. With Onshape, it's all SaaS based, so there's no IT support. All you get is a user login. All that tool is based in the cloud, so I don't have to update my software, keep the current revisions, worry about a PDM system. It's all there for me. My IT department has really nothing to do with how I'm working with this tool. The existing tools, they breed the culture for serial or sequential based operations, where we do something, we hand it to somebody else, they do something, we hand that to somebody else, and then they do something. Here in this cloud-based environment, we can work collaboratively with other users, as you saw in the demonstration. Okay, so these processes are really rigid and controlled and not very flexible. So we have a lot of flexibility working with this tool. And then we don't risk losing our IP data, by sending these files from one user to another, or to our suppliers or customers or what have you, right? So if we can reimagine what this product development process looks like, it involves the cloud, right? And this is the cloud. Okay, the cloud is Amazon Web Services, right? So we basically have a bank of computers, drives that basically represent the cloud. So who knows what's there, right? It's the cloud. So if we think about the different levels of infrastructure or platform-based or software as a service implementations, a lot of what we see today or in the past have been all user managed, where the application, the system, the storage, the servers are all managed by the end user or by the IT department in our customers, right? A lot of them now are moving to a provider managed, where we're seeing our PDM systems in the cloud, or networking and storage. All that is done in the cloud, but we still have a lot of the application, the data, middleware, operating system is all managed locally. Okay. Platform as a service, now we're seeing a lot where we just have the application and the data is local, but almost everything is done kind of as a service. But with Onshape, it's a true service or software as a service platform, where all you have is an end user login, and you can access the data from any type of device, whether it be a laptop computer, or a desktop computer, tablet, you name it, even your cell phone. Today's cell phones, you can access this information. Okay, so the benefits of software as a service is, instant deployment, no downloads, installs, or upgrades, service packs, or license codes. It's all in the cloud. You don't have to do anything other than log in, right? And I can't tell you how much time I have spent helping customers install new versions, solve license issues, find their data, just understand the tool itself. All of it's available right at your fingertips within the cloud. So there's no IT overhead. And I want to say, maybe there's a little bit, because there could be some configuration that needs to take place when you move to Onshape. You might want to create some formats or things like that, some release workflows. So there might be a little bit of overhead, but very little. And the database is centralized, right? It's all in the cloud, Amazon Web Services. You always have access to the latest version. You're not sharing or copying. You're not copying data. It's all shared in real time. And you have full audit trails of the data, reports, and analytics. And in future webinars, we're going to get into some more information and some more advanced capabilities with release schemes and so on. So with that, I'd like to open it up for questions. I'm going to go ahead and open up my question board here and see if we do have any questions. I'm not seeing any right now, but if you do have questions, please let me know. Okay, I'm not seeing any questions, so what we'll do is we'll wrap it up here. And what I want to say is, if you have any questions that come to mind, please feel free to reach out. You have my email address here on the screen. If you're interested in getting a quote or maybe a more in-depth demonstration, you can reach out to us or reach out to your sales rep from TriStar. And so with that, I'll let everybody go. Alex, is there anything that you'd like to add?
No, I think we're good. As Shawn said, definitely visit TriStar.com. You can request a demonstration, kind of get into the weeds a little bit more if you have specific needs, as well as a request a 14-day free trial. Again, just TriStar.com. So with that, thank you, Shawn. That was excellent. And I hope everyone has a great weekend.
Thank you, everybody.